Now members, let us see how to get the cumulative distribution function of a uniform or a rectangular distribution. As you've seen from continuous, the same way we handle this when we are getting the cumulative. So we say, remember we get x. So for x below a, but you see, we get for x below a, but we say, if it's below a, this function means f of x is 0. And if f of x is 0, it means that even capital f of x will be 0. So it's so that there f of x is 0, which implies that below this, even our capital F of x will be 0. And so at that interval, you got it. Now you come to the next interval of a less x. Let's equal to b. What will be there? So you see that there, our function now is given by our f of x there, and that interval is given by 1 over d minus a. So now, we need probability, our capital F of x, we say is the probability of x less or equal to x. So meaning, we are going to integrate this from our lower limit up to when we reach x, then we change that function. So this will be now integral from the lower limit up to when we reach x of now, we change the variable to t. This is just a dummy variable, but you see now, if there I get also f of t, it will be 1 over b minus a, because this is a constant function. So now, when we integrate that, you see that this will be now the same as integral from a to x, now f of t dt. When we integrate this, we get, 1 over a minus b is a constant. Interpret that we get, okay. I'd skip the step, but this is just t. We integrate the t, we get t. Then from a to x, substituting in that limit, we get 1 over b minus a into x minus a. And so you see that here, our capital F of x will be x minus a over b minus a. So after that, we are going now to read. We say we substitute this upper limit to know the value we are carrying. So our f of b will be b minus a over b minus a, which will be a 1. That one is always clear. So after doing that, now we come and we get for x above this. For x above b, then we say if it's above b, we say that our f of x doesn't exist because of this idea. We say that this one is defined between a and b, so above b, it's 0. That's what we mean by 0 elsewhere. So meaning that it doesn't exist. So our f of x will be this one, then plus the function, but this is, if this is 0, even this capital F will be 0, and so it will be a 1. So here I'm going to add on and hence sketch. Okay, I will add it later there. So now sketch my capital F, write this capital F of x. This will be, so we have it's 0 when x is less or equal to a. Then we have seen between this range, it's x minus a over b minus a when a is between. Then we've seen, and then we've seen that it's a 1 when x is greater or equal to a b. And so that's the idea. So let me add here another thing that, and hence sketch, and here's sketch capital F of x. So let me add it there. So this is our capital F of x. Now we are going to sketch it. To sketch it, we need these two ideas here. This is the line with a positive gradient. So our sketch is going to be very easy. So it's 0 below x equaling to a. Then what about in this range? So you just substitute there and you see when my capital F of x is equal to x minus a over b minus a. When x, we put in the lower limit. When x is a, it's that our f of a. When you put here a, you shall get a 0. When x is b, what do we get? Our f of b. So that when you substitute the b here, you shall get a 1. And then above this is also 1. So to sketch it, you get your ruler. Then we are plotting capital F of x against x with ease. But the sketch would have been easy because we said that it's a line. So this is capital F of x, and this is going to be my x. How do I sketch? You know, I have, of course, I'm going to go from 0. So this is going to be my 0. And I'm going to consider this to be my a. And I consider this to be my b. This is the sketch. Then f of x is that we have 0. And then we have this 0 when x is a. You know, this is 0 when x is a. We have seen this 0, and then when x is b, it's just 1. So we have for a, when x is a, our f of x is 0, so here it's 0. Then what about when we had a b, it's on a 1. So, meaning this is going to be, if this is my 1 there, then we have when it's a, it's 0. Then when it's b, it's 1. So our b, when it's b, our capital f of x is 1. Then we plot this here. So this is the one from A to B. From A to B, our capital F of x is x, b minus a. Then above b, it's a 1. Above b, it's a 1, which you can ably draw like that. Above b, this is our 1 there. And so there, they have finished that sketch with ease. So this is above b, it's just a 1 as you can see there. So this is our f of x equal to a 1 with ease. So that's how we sketch that. So I leave it at that. You see that this was a line with a positive gradient, and it's still there. See you.